In this video, we are going to look at rational exponents. So rational means a fraction, and you know what exponent means. It's the power that's above a number or variable. So let's start with looking at what a rational exponent is, and then we'll look at operations with them. So if you have an exponent that is a fraction, okay, an exponent that is a fraction. If m is 1, then this fraction is just n. So a to the n is the exponent that you know all along. Okay, so the n part is your regular exponent, like x squared, x cubed, whatever. The fraction part is the root. So this is the same as m, the mth root of a to the n, or the mth root of a to the n. And you can organize it either way like that. So if you're simplifying these, let's say you've got 8 to the 2/3. So that would be the cube root of 8 squared, or the cube root of 8 squared. Okay, both of those should come out the same. So the cube root of, if we do so this is just order of operations, right? Which one we do first. So this one says do the cube root first. That's 2, and then square it would be 4. This one says square it first. That would be 64, and then take the cube root, and you still get 4. So the order doesn't matter. If you can take the root first, that's usually the better way to go because the numbers stay smaller, but you can't always. So sometimes you have to do the exponent first and then simplify the root. All right, so let's just take a look at a few more of these. So let's say we've got 16 to the 1/4. So the exponent is 1. That doesn't do anything. This would just be the 4th root of 16. And remember from last time, we're looking for something that multiplies 4 times. So 2 times 2 times 2 times 2 would be the 4th root of 16. Okay, let's say that we have 4 to the 5/2. Okay, so we're raising it to the 5th, and this is the 2nd root. Remember, the 2nd root is the squared root. We don't usually write it there. So when you have the 2nd root, you would just write it as a square root. You can put a 2 there. It's not going to hurt anything. We just don't usually do that. So I'm trying to decide, do I want to do the root first or the exponent first? So I think, okay, can I do the square root of 4? I can. So let's do that first and then raise it to the 5th. So square root of 4 is 2, and then raised to the 5th would be 32. Okay, so that's simplifying some rational exponents. Now, if we're looking at let's say we've got a negative inside of the root. So exponent 1/2 would be a square root, and we've got a -4 on the inside. Okay, that we know that taking a negative of a square root is not a real number. All right, so when we see, you might not see it in this form, but when you see it as a root, you go, oh yeah, that's not a real number. But if you have -4 to the 1/2, exponents only go with what they're next to unless there are parentheses telling you otherwise. So this negative is outside of the exponent because there's no parentheses around it. So this one I can do. I would do the square root first and then make it negative. All right, and if, of course, if you have, we talked about this before with the other roots. If you have something like this, you've got -8 to the 1/3. 1/3 is a cube root, and I can take the cube root of a negative number. So -2 times -2 times -2 would give me -8. Okay, so that is what you do with a rational exponent. So you change it to the root and the exponent. Okay, so now working with these, let's just review exponent rules. These should be familiar to you, but sometimes we just kind of do them out of habit. We don't really think about the rule, and then when it gets to like these rational exponents, you have to remember what the rule is to be able to work with it. So the first one, if I multiply x to the m times x to the n, so the bases match, and I would add the exponents. Okay, so I'm going to add the exponents. So thinking of just a simple example, in case if you forget this or it doesn't make sense to you. If you do x squared times x cubed, what the exponent means is that you're multiplying it out that many times. So x squared means that you have 2 of them, x cubed means you have 3 of them. It's all multiplication, so when you put it together, you've got 5 of them. All right, so that's basically what exponents mean. Sorry, that was my alarm. Okay, and then if we've got a fraction, we're going to subtract the exponents. Okay, so for example, if we have x cubed over x squared, we've got 3 on top and 2 on the bottom. 2 of them cancel out. So basically we're taking the 3 that are on top and we're taking away the 2 that are on the bottom, and we get x to the 1, or just x. Okay, so 3 minus 2 would be 1 left over. We have 1x left on top. Next one, raising a base to 2 exponents. Okay, now this is different from the first one. The first one we're multiplying 2 things with matching bases. This is one base with 2 exponents. So when we do that, we're going to have x to the mn. So this would be like x squared cubed. See the difference here? So this would be x squared times x squared times x squared. That would give me a total of 6 of them, because I've got 2 plus 2 plus 2, which is 2 times 3, which gives me x to the 6th. So the way that you can remember the difference between the two of these is, remember, anytime things are, I should say almost anytime things are separated by parentheses, it usually means multiplication. So I've got 2 times 3 because of the parentheses. All right, and if we have 2 different bases raised to 1 exponent. So this one is different because all of these were the same base. These are 2 different bases raised to the same exponent. Now, this is the one time that you can distribute an exponent because it's over multiplication. You cannot distribute an exponent over addition or subtraction. So for example, let's say we have xy squared. The reason why we can do this is because it's x times y times x times y. Multiplication I can regroup, and that gives me x squared y squared. So because it's all multiplication, I can regroup it and then put the exponents back in. All right, and then these two I'm going to put here, and we're going to talk about them some more. So anything to the 0 is 1, and anything to a negative exponent is a fraction. Okay, so anything to the 0 is 1, and anything with a negative exponent means reciprocal. All right, those are not easy to see right away. So what we're going to do is we're going to look at an example. Okay, so let's say that we're looking at powers of 2, or I guess exponents on base 2. That'd be a better way to put that. Okay, so let's say we have 2 cubed. We know that that's 8. 2 squared is 4. 2 to the 1 is 2. Okay, so see what's happening as we go down in exponents. Usually we go up in exponents, we multiply by 2. So if we go backwards, we go down in exponents, we're dividing by 2. So I go from 8 to 4, 4 to 2. If I do one more, I would have to divide by 2 again, right? So this is like 2 times 2 times 2. I've got 3 factors of 2, 2 factors of 2, 1 factor of 2, no factors of 2. So if we divide 2 out, we're left with a 1. Now what happens if I divide by 2 again? I should get 1/2. And divide by 2 again, I would get 1 over 1/2 times 1/2, or 1 over 2 squared would be 1/4. And then this would be 1/8. So if you notice, the negative exponents are the same as the positive exponents, just reciprocal. Okay, let's look at base 3. So 3 cubed is 3 times 3 times 3 is 27. 3 squared is 9. 3 to the 1 is 3. So now we see we're dropping by a factor of 3 each time. So divide by 3, divide by 3, divide by 3. We get 1, not 0. Divide by 3 again. We get 1/3. Divide by 3 again. We get 1/9. Divide by 3 again. We get 1 over 27, and so on. And you see here there are these numbers and these numbers are reciprocals. So if you can do positive exponents, you can do 0 and negative exponents. They're really the same thing, just reciprocal.